So today we're going to cover section 3 from chapter 5. And today we're going to learn our first shortcut for proving triangles congruent. Now, in the lesson that we learned prior to this, in order to prove something was congruent, you had to show every single side and every single angle is congruent. Now, when we start learning these shortcuts, now we're only going to have to find 3 pieces of information to show that they're congruent. So, first thing we need to do is define some vocabulary words. So this slide is talking about the included sides and the included angles. When I refer to an included side, I mean that it's going to be the side that's included between the given angles. So for example, side AB is going to be the side that's in between angles A and B. The included angle is the angle where the given sides meet. So for example, if I'm talking about included angle C, I'm talking about the 2 sides that are going to make up that angle. So in reference to the red triangle that's down here, so notice when I'm talking about the included side, so I'm talking about side AB, which is here, that's going to be the side that's in between angle A and angle B. If I just said find a side, I could say AC or BC, but when it's referring to an included side, they're going to reference the 2 angles that are there. For the included angle, that's going to be like angle C, and the sides that makes it up, that would be the included angle. So you would be given, say, sides AC and CB. So it's the angle that is in between the 2 sides that make the angle. So let's see what this first shortcut is. And the first shortcut is called the side angle side congruence theorem. When you use this theorem as a reason and a proof, all you have to put is SAS. You don't have to write out side angle side. If you want to, you can. And what this theorem states is if 2 sides and the included angle, so here's that vocab word, of a triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. And I'm going to draw an example. I'm going to draw that bow tie looking thing again. I'm going to draw it down here. So if I draw my 2 triangles, I'm going to add letters, A, B, C, D, and E. So in order to prove these triangles are congruent, we would need a side, another side with a marking, and then the angle that is formed by the 2 sides that are marked. So I could use these vertical angles here. So instead of showing all 3 sides are congruent and all 3 angles, now I can get away with just finding 3 pieces of congruent information to prove my triangle congruent. However, they've got to be specific sides and specific angles that have the congruency marks. So here we can match it with 2 sides and the included angle. So if they ask you to write a congruency statement for these 2 triangles, the order of the letters is important. Everything needs to match. So for example, I could come up with the statement. Generally, the first one will be alphabetical. So I could say triangle ABE is congruent. Now the second one will not be alphabetical, or it may, but it's got to match now. So is congruent to DBC. And if you look at it, you can see how they match. So you can see that angle A here is going to match with D because they're the first 2 letters. And notice it's like at the end of this side that has the single tick mark. And then you can see that B is going to match with B. It's the vertical angle here in the middle. Now, if we were naming this in a proof, we couldn't say B is congruent to B. We would have to name that angle with 3 letters. And then finally, we can also say that C and E match. So the order of the letters in this statement will tell you which one matches where. All right, so let's take a look at the first one. And the instructions say, state which congruence methods could be used to prove the triangles are congruent. If none, state NC. Well, we've only learned one shortcut. So basically, of these 5 examples, we're looking to find which one is side angle side. So now, the first triangle, now remember, whenever 2 triangles are sharing a side, so if I were to pull this apart, I would be referring to this one on the left and this one on the right. Now, this side where it's both red and blue is congruent to itself. When we go to write proofs, we would state that that side is congruent to itself, and the reason would be reflexive. Now, if you look at the triangle here now, notice I've got a side that's marked, I've got an angle that's marked, and then I can do the side that they share. Now, in order to prove this by side angle side, it would have needed to have this angle right here marked with this one. So there is no shortcut called ASS. It's not because it's not a nice word, it's just there is no shortcut that is in that order of those letters. Again, it would have to have the angle that's formed by the 2 sides that have the congruency marks. So this example, there is no congruence here. You can't assume that this angle down here is right. It needs the little box. Now, I know on the next one, it looks like there's the little squiggly lines. Those I have actually drawn them in there. So it's what we were given here is that this angle is congruent to this. This is just a random mark. Get rid of that. And then we also have these sides marked as congruent. Now, if this is a right angle, then I know this one's also a right angle because it's on a straight angle or a straight line. So, and then again, I've got the side that they share is congruent. So what you're going to do is when you go to try to label what's got the markings, pick a point and then rotate it around the figure. So the first thing that I can see marked is a side that's congruent. Then as I go around my figure, the next thing I'm coming to is an angle that's marked. And then as I go down this side of the triangle, a side is marked. Same thing on the other one, a side to an angle to the same side. So yes, these are congruent by side, angle, side. We're going to learn some other ones. We're going to learn an angle, side angle, and a hypotenuse leg. Those will be also. So this one could actually be done with several of the shortcuts, but at this point, all we've learned is one. Let's try the next one. It looks like the bow tie. Now remember, anytime you have something like this, like the bow tie, you can always label the vertical angles. Those are congruent. Let me give them different markings. Now, I need to see if there's enough information to prove that these are congruent. So right now, I've got a side that's marked. I've got an angle, but these 2 angles don't have the same marking. So they're not congruent to themselves. So that doesn't even help me. And then the other thing I just put in here was the angle, the vertical angles. just having two pieces of congruent information is not enough. So even though they look like they're the same size and shape, I can't officially prove that these are congruent. So this is no congruent. These don't have the same markings here. Let's try the next one. This one is actually the same as B. So this is congruent by side, angle, side. Side to the angle to the side here. And then the last one on this slide, I do not have any kind of sides marked here. I do have an angle, and another angle that are all matching. However, there is no shortcut or short way to prove angle, angle, angle. So this one is no congruence. Because if you think about it, and we're going to talk about equilateral and isosceles triangles, but for example, if I were to draw a little equilateral triangle and then a bigger one, all the angles could be 60 degrees, but this side, these could all be 2s, and these could all be 5s. And these are not congruent triangles, and it's not even showing up. Let's see. Let me draw it in here. Maybe I need to draw it in the picture. Yep, okay. So let's say I have a little one and a big one, and let's say these are all 60 degrees. Obviously, these are not going to be the same size. They are the same shape, but they're not congruent. So this is why there's no angle, angle, angle shortcut, because they could have the same angles, but they would not be congruent. So we just established that the top angle here was congruent to this piece here. So we can say that these are congruent by side, angle, side. So it just wanted us to establish if there was enough information. And there is. So the next one says, state a third congruence you would need to prove the triangles are congruent by side, angle, side. So let's go ahead and add in the congruency marks of what is given to us. So they gave us that ST is congruent to YZ, and RS is congruent to XY. In order to use side, angle, side, I would need to establish that angle S is congruent to angle Y, because again, remember, it needs to be the angle that is formed by the two sides that are marked as congruent. So my third piece of information would be to establish that angle S is congruent to angle Y. Then I could use side, angle, side. Now, if the instruction said, state a third congruence to prove the triangle's congruent by side, 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 then we would have added tick marks to this side to show it matched here. That's going to be another shortcut that's coming up. We're going to learn later on about side, side, side. And the last slide is a proof. It's going to be short proof, 4 steps. So here, the picture's already labeled for us. They gave us that BC is congruent to DA and BC is parallel to AD. So here what I need to do is prove that this triangle, ABC, is congruent to this one, CDA. So let's go ahead and first state our given. So we'll make our statement column and our reason column. And now we're going to state the given. we're going to state that BC is congruent to DA, and BC is also parallel to AD. That was given. Now, the next two steps you could flip-flop. I'm going to go ahead and do the reflexive first. I'm going to say that this side, AC, is congruent to itself. So AC is congruent to AC, and that's the reflexive property. And that's property of congruence, POC, or property of, and you can put the congruent symbol. If you just put reflexive, that's fine. I don't need to see property of congruence. Now, the next thing is they told us that we had some parallel lines here. So this one is parallel here to this one. So again, this AC, I could think of my transversal, which is now going to create alternate interior angles. So I could say that BCA is congruent to DAC. And that reason is alternate interior angles theorem. I'm just abbreviating. So alternate interior angles theorem. Now I have enough information. I've got a side marked, the included angle, and a side. Same thing here. The side, the included angle, and the side. So now what I was asked to prove is my very last statement. So triangle ABC is congruent to triangle CDA, and my reason is side angle side. You don't need to put congruence theorem. If you put it, that's fine. All I need to see is side angle side. So that is it for your first shortcut method for proving triangles congruent. So the homework for this lesson is due on Friday. Your homework tonight is the 5-2, which is what I taught yesterday. So we have the 5-2 homework due tomorrow. Then tomorrow we'll go over the 5-2 homework, and I'll work anything out that you want to see from 5-2 tomorrow. Okay, I'm going to go back to example 3 here.